Motion is the movement of an object. This seems simple, but there's a whole lot of physics happening. And thanks in part to scientists like this guy, we have some universal ways to describe, measure, and calculate motion using these key concepts. First, an object must be somewhere. This is called its position. In order to be moving, the object must change position. Then we have to consider its direction. Depending on what's moving, where it starts, and what we're trying to measure, we can use directions such as east, west, up, down, or left and right. Then there's distance, the measurement of how much space an object has covered with its movement. And displacement, the measurement of how far the object moves from its original position. So if an object moves like this, the distance and displacement are the same. If it moves like this, the distance is different from the displacement. And for this example, the distance is great, but the displacement is 0. Intuitive or not, these variables help to describe motion. So something as simple as a ball roll to something as complex as the movement of the universe starts with these basic concepts. Beyond the position, direction, distance, and displacement of an object, other important factors in this whole motion thing are speed and velocity. Speed is the measurement of how far an object moves, divided by how long it takes to move. And although the concepts of fast and slow are pretty obvious to the casual observer, the speed of an object is a measurement of the distance divided by the time. Miles per hour, meters per second, inches per year. Things can move at a constant rate or move at changing rates. You can measure the speed at a certain instant or an overall average speed of the entirety of the movement. Because it's measuring distance over time, these are all measurements of speed. Then there is velocity. Velocity is similar to speed, but it measures time, distance, and direction of an object. So 15 miles per hour is a measurement of speed, but 15 miles per hour west is its velocity. Velocity comes in handy when your simple trip becomes a bit less simple. Each of these measurements, speed and velocity, help to describe the motion of an object, which comes in handy for all the things that move in your life.
The Earth revolves around the Sun and a kicker makes the field go and a ball rotates. But what makes this change in motion? Simplified down to its most basic definition, and that is forces. A force is a push or pull that has a magnitude and a direction. Forces can start motion when one is bigger than the other or unbalanced, like kicking a ball. And forces can also stop or change in motion, means ball hitting a wall and bouncing off. There are all kinds of different forces acting in different ways and direction all the time. Friction, for instance, is a force between two forces that slows movement down. Gravity is a force that can slow an object down or speed it up, depending on which direction the object is moving, and magnetic force can do the same thing. Forces are also at play when something is not moving, a ball resting on a table, for instance. Both the downward force of the gravity and the upward force of the table are equal. The forces acting upon it are balanced and the ball is not in motion. And understanding these forces and how they affect things around us come in handy whether you are a physicist, an athlete, or an aspiring pool shark.
When measuring and describing motion, there are a lot of details to capture, and it can involve a ton of complicated math. But it turns out graphs are an easy way to visualize motion, if you know how to interpret them. It can get tricky, so we'll break it down to the basics. The most basic motion graphs map out the position of an object over a timeline. As time ticks by and the object moves, or doesn't, it will be plotted out in different positions along the timeline. So, if an object is sitting still for 10 seconds, the graph will look like this. If an object moves from one place to another at a constant speed, its graph looks like this. If an object starts, then stops, then starts and stops, and then moves back to its original position, its graph looks like this. If the slope of the line is steep, it traveled from here to there fast. If the slope is shallow, the object took its sweet time. From a single motion graph, you can tell distance traveled, displacement, speed, velocity, and all kinds of information about its motion and path, while skipping most of the complicated math.